Good afternoon, ladies and gentlemen. Today we're gonna continue with the string theory with Mr. William, and he's gonna talk about special relativity and the general relativity. So, Mr. William, it's all yours.
Okay. So the first thing I want to talk about is special relativity. Special relativity is a theory that came up by Einstein. Now, what we're used to and what we learn in school is Newtonian like physics. So everything, if you push something, accelerates it, eventually it can just keep on going up, velocity, and the velocity increases. Einstein started to realize that this doesn't really work. As you get closer to the speed of light, nothing can travel faster than the speed of light. So it kind of breaks down when you get closer to the speed of light. Now he came up with basically a thought experiment, which shows that each person traveling at different speeds has their own reference frame. Now this isn't speeds we're talking about like in a car. This is speeds that are a lot faster than that. So what he thought was, since light is always constant at a constant speed, that if someone is traveling on a train and he shoots a light beam straight down, all he would see is the light go down, then it bounces back up. Okay? So, that being said, if someone is looking from the outside at this person who's doing this weird experiment with a flashlight on a train that's going really fast, he's going to see the light not bounce down and back up. He's going to see the light travel because the train's traveling. He's going to see it go like that and then bounce back up. So, that being said, because of that, that angle's a little bit wrong, we can tell that each reference frame is a little bit different depending on your speed. In context, what that means is if we have someone that's traveling really fast in a fast spaceship, leaves Earth, has a twin, his twin brother is here, he could travel around to different planets going really fast, close to the speed of light, and it could be a couple of years for him. When he lands back on Earth, the person here will be a lot older. His twin might even be an old man or age 40 years compared to 2 years that he aged. So the faster you're going, the more time slows down relative to someone at rest like us.
Wow. So what's the difference? Now you talk about the special relativity. What about the general relativity?
So general relativity is basically that time and space are interwoven. So they are kind of like, if you were to think about it, a fabric like this. Okay. If this is time and space, anything that goes into the fabric that has gravitational force will distort that area. So this is something where we look at if an object is further out in space and they experience less gravitational force, the time will move faster for them. Now, these two things have been proven to all of our knowledge and science and satellites that they are real. We can see that if you put an atomic clock, so they are the most accurate clocks possible, on a spaceship and have it traveling up to space, they start to experience time a little bit different than us. And that's the whole thing, is that, so speed and gravity affects how time is perceived. If you've seen the movie Interstellar, that's what you see when you watch the movie, is that you see that some characters will age a lot differently if they're on a spaceship compared to Earth. And time is all relative to your reference point. So that means that time is not a constant thing. It's more fluid. It changes depending on how fast we're going and as well the gravity that we experience.
So if you put all this, the general and the special, what knowledge do you want the people to gather from all this information you're giving out about string theory and about physics?
So for special and general relativity, there were two big theories that Einstein made, and they are a basis of a lot of our modern day science. It starts looking at things on the quantum level instead of things on the, basically like units that Newton came up with. So Newtonian physics was basically shown to not be the end all and be all that it used to be thought. That used to thought to be. So when we look at these different relativities, it shows that as we get closer, or as we start looking at things smaller, the dynamics changes. As we start looking at things as they go faster, it changes. So our understanding of what the world is by what we can perceive, it actually changes as we start to look deeper into it. So then it starts to lay the foundations of what eventually would start to be string theories, and the basis of what a lot of string theory arguments and mathematics are based off of. Now, these two theories are also argued to not be 100% correct, and then they start adding extra stuff onto it when it comes to some different scientists when they argue string theory.
That's wonderful. That's just wonderful. So this is what we're gonna give you guys today. The thing about the AC podcast, it's about educational. We impact knowledge on people, and it's about fun. It's about I'm gonna say it's about a life, in general, And I remember when I was coming up, the best students in the class is the one that listen. So I was not a big speaker, but I was a listener. So for my advice today, educate yourself. Corona is still out there, and I want to say thank you to Mr. William, and I want to say to the public out there, enjoy yourself, be safe. We out.